Okay, so this is where we left off in the last video. We had 3 more of those diagrams to do. I thought there was 2, but there are 3. So let's finish these up. Again, we're looking at horizontal rock layers, putting them in age order. Typically, oldest is at the bottom, getting progressively younger. There are situations where that's not true. But anyway, if we take a look at this one, our oldest rock would be down here, number 1, the sandstone. Then we would go up to the limestone. There's 2. We have our conglomerate, 3. We have our shale as number 4. But now things get a little more complicated because in this diagram we have a fault and we also have an igneous intrusion. And we have to decide, well, which one of those came first? And the fact that the igneous intrusion, the lava or magma, cuts across the fault, that means that our 5th event would be the fault, and our final event would have to be the intrusion and contact metamorphism again. So we have the intrusion, or we have the fault happening first, and then the intrusion cuts across the fault. This is an idea of what's called cross-cutting relationships. And it helps us figure out the sequence. What came first, what came second, and so on. And the fact that the fault cuts across all the layers of rock tells us that the fault had to have occurred after the rocks were formed. And then the intrusion cuts across the fault, so that had to have come after the faulting. That means that our youngest event would be the intrusion. Or maybe you could make an argument for contact metamorphism happening last. Okay, then we have 8 and 9 down here. These are the most complicated ones. So let's take a look at them, and we'll start with 8, obviously. Okay, so with 8, we have, again, sedimentary rock layers. We can predict that the oldest is going to be at the bottom. So our oldest one is going to be number 1, the shale, and then we're going to go limestone, siltstone, sandstone, 1, 2, 3, 4. That part's probably pretty obvious. And the shale is our oldest. That's going to be at the bottom. And now we have an intrusion and we have a fault. But in this situation, it's in most ways the opposite of what we had in problem 7. Because here the intrusion is cutting across the fault. In this example, the fault is cutting across the intrusion. So what this means is that number 5 had to have been the intrusion, along with the contact metamorphism. And then number 6 would have to be, lastly, the fault. The fault cuts across the intrusion, so the fault would have to be the youngest feature in this diagram. So that would be the fault. And then number 9, much more complex. Here we go 1, 2, 3, 4, 5. Our first one is the oldest. That's the siltstone. And now we have some other features happening here too. We have 2 intrusions. And if we look at this one, well, the magma intruded its way through these rocks and then spilled out and created this kind of bubble here. This happens sometimes. And it can actually create a dome on the surface and create it like a hill or a mountain. But anyway, the fact that we have contact metamorphism all around this pool of magma tells us that the magma came after 4 and 5, rock layers 4 and 5. We looked at a different example where the magma came first and then the sediment was deposited on top of the hardened magma. And we can tell because of the contact metamorphism. The fact that these rocks have been metamorphosed all around, not only on the bottom but also on the top, tells us that these rocks were already here. This fold is due to the magma bubble basically pushing up on it and bending it. So feature 6 would be the first magma intrusion. And again, we have contact metamorphism. Then we have the second intrusion cutting across the first, which means that this intrusion is the youngest. So this would be the younger of the two, and this would be the older. So this one had to have been here first, originally, and then this intrusion comes second and cuts across the older one. So we have a sequence where we have our original sedimentary depositional sequence, 1, 2, 3, 4, 5. Then we have this intrusion come in. It's causing contact metamorphism. Again, the sedimentary rocks are being altered by the heat and turned into their metamorphic counterparts. Then we have contact metamorphism all around. New intrusion over here. Okay, so this is the idea of relative dating. We could look at order and we could put things into proper sequence. Now this week, the lab that I'd like you to do has to do with this idea of putting things in order. Later in the week, we'll take a look at radioactive decay, and this week we'll just look at relative dating. So that's all for now.